What if the Ice Age didn't bury an empty world, but the ruins of one that came before? For most of human history, we have told ourselves a comforting story. That civilization began recently, a mere 6,000 years ago, in the river valleys of Mesopotamia and Egypt. That before those first cities, there was only wilderness, only scattered bands of hunter-gatherers living hand-to-mouth, leaving nothing behind but stone tools and cave paintings. But this story requires us to ignore a troubling fact, that modern humans, anatomically and neurologically identical to us, have existed for at least 2,000 years, perhaps longer. For 95% of that span, we are told, they did nothing. They invented nothing. They built nothing that lasted. Then, suddenly, as if by magic, they learned to farm, to write, to construct temples and pyramids, and observe the stars with precision that wouldn't be matched for millennia. The timeline doesn't make sense. The gap is too vast, the leap too sudden. And in that gap, in those missing millennia, lies a possibility that conventional history refuses to consider, that civilization is far older than we have been taught, that it has risen and fallen multiple times, and that the last time it fell, the ice came and buried everything. The Ice Age was not a single event, but a series of glacial and interglacial periods stretching back millions of years, cycles of freezing and thawing driven by variations in Earth's orbit and axial tilt. The most recent glacial period, the one we call the Ice Age, with capital letters, began roughly 15,000 years ago and reached its peak around 2,000 years ago during the last glacial maximum. At that point, ice sheets more than 2 miles thick covered Canada, northern Europe, and parts of Asia. Sea levels dropped by 400 feet as water was locked into the glaciers, exposing vast continental shelves that are now submerged beneath the oceans. The coastlines of every continent were dramatically different. The Persian Gulf was dry land. The Mediterranean was smaller. Indonesia and Malaysia were connected by land bridges. The English Channel didn't exist. And between these altered landmasses stretched plains, river valleys, and coastal regions, where the climate was temperate, where animals grazed, where rivers flowed, where, in other words, human beings could have lived, built, and thrived. Then, starting around 15,000 years ago, the ice began to melt, not gradually but in catastrophic pulses. Meltwater Pulse 1A, around 14,600 years ago, raised global sea levels by 50 feet in less than 500 years. Entire landscapes vanished beneath the rising oceans. If there were cities on those coasts, they are now under hundreds of feet of water, invisible to archaeology, erased from the record as completely as if they had never existed. Conventional archaeology operates under a principle called uniformitarianism, the assumption that the processes shaping the Earth today operated the same way in the past: slow, gradual, predictable. Coastlines erode slowly. Sediment accumulates slowly. Civilizations develop slowly, each stage building upon the last in a neat progression from simple to complex. But this principle, useful as it is, breaks down in the face of catastrophic events. The end of the Ice Age was not slow or gradual. It was violent, chaotic, marked by floods, earthquakes, volcanic eruptions, and climate shifts so rapid that ecosystems collapsed and species went extinct within generations. The Younger Dryas, a sudden return to glacial cold that lasted from 2800 to 1100 years ago, interrupted the warming trend and may have been triggered by a comet impact or airburst over North America, an event that set the continent on fire, melted ice sheets, and sent a flood of fresh water into the North Atlantic, disrupting ocean currents and plunging the world back into winter. When the cold finally broke, the melt was catastrophic. The Black Sea, once a freshwater lake, was inundated by the Mediterranean in what may have been the largest flood in human memory, a deluge so sudden and destructive that it entered the mythology of every culture in the region. If civilizations existed before these events, they would have been erased, not slowly buried by time, but drowned in days, frozen in decades, obliterated so completely that only fragments would remain. And fragments do remain, scattered across the world, in forms so anomalous that archaeology struggles to explain them. There are structures that predate the accepted timeline of civilization by thousands of years. Göbekli Tepe in Turkey, built around 9600 BCE by people who were supposed to be nomadic hunter-gatherers, consists of massive stone pillars arranged in circular enclosures, carved with intricate reliefs of animals and abstract symbols. The engineering required to quarry, transport and erect stones weighing up to 16 tons implies organization, specialization and accumulated knowledge that should not exist in the Neolithic. Yet there it stands, older than the pyramids, older than Stonehenge, older than the first cities of Sumer. Across the ocean, Gunung Padang in Indonesia, a megalithic site built on a volcanic hill, has been dated through core samples and ground-penetrating radar to layers extending back 2,000 years, deep into the last ice age. Mainstream archaeologists reject this dating, calling it impossible, but the data persists, suggesting that construction occurred in multiple phases, the oldest of which would place human architectural activity in an era we have classified as prehistoric. These are not isolated anomalies. They are part of a pattern, a global distribution of ancient sites that appear suddenly in the archaeological record, fully formed, with no clear antecedents, as though they were built by people who already knew what they were doing. The question that haunts these discoveries is simple: where did the knowledge come from? Göbekli Tepe was not built by people experimenting with stone for the first time. The precision of the cuts, the consistency of the symbolism, the astronomical alignments embedded in the structure all point to inherited expertise, to a tradition of building that predates the site itself. But if that tradition existed, where are the earlier examples? Where are the mistakes, the failed experiments, the gradual refinement of technique? They are not there. Or rather, they are not visible, because they are buried beneath the ice, submerged beneath the seas, or eroded beyond recognition by 12,000 years of weathering. The Ice Age would have destroyed almost everything. Wood rots, mud brick dissolves, metal corrodes. Only stone endures, and only if it is massive enough and well-placed enough to survive the glacier's grinding advance and the flood's scouring retreat. If a civilization rose during the previous interglacial period, the Eemian, which lasted from 13,000 to 15,000 years ago, almost nothing of it would remain. The glaciers would have pulverized their cities, the sea level rise would have drowned their ports, and the 100,000 years since would have reduced even stone to rubble, indistinguishable from natural geology unless one knew exactly where to look and what to look for. We are only beginning to learn how to look. Satellite imaging, LiDAR, ground-penetrating radar, sonar mapping of the ocean floor. These technologies are revealing landscapes hidden beneath jungle canopy, desert sands, and ocean waters, and what they are finding is unsettling. Off the coast of India, in the Gulf of Cambay, sonar has detected geometric structures 120 feet below the surface in areas that were dry land during the Ice Age. Near the Bahamas, underwater formations like the Bimini Road display alignments and right angles that some researchers argue are too regular to be natural, though others maintain they are simply beach rock formations shaped by erosion. Off the coast of Japan, the Yonaguni Monument, a massive stone structure with terraces, steps and right-angled corners, has sparked decades of debate over whether it is a natural formation or a human-made temple submerged when sea levels rose. Mainstream geology leans toward natural, but the features are so architectural, so deliberate in appearance, that the question refuses to die. And in each case, the chronology is the same. These structures, if artificial, would have been built before the flood, before the meltwater pulse, when the coastlines were lower and the lands now drowned were inhabited. If they are natural, they are extraordinary coincidences. If they are artificial, they rewrite history. But perhaps the most compelling evidence lies not in what we have found, but in what we have not found, the absence of early human civilization in the places we have looked, and the presence of it in places we cannot reach. The continental shelves, those submerged plains that once ringed every landmass, were prime real estate during the Ice Age, fertile, temperate, well-watered, teeming with game. If human beings were going to settle anywhere, it would have been there, along the coasts, near the river mouths, in the deltas and estuaries that provided everything a community needed to thrive. And those are precisely the areas now, under 300 to 400 feet of seawater, inaccessible to conventional archaeology, surveyed only in fragments by marine geologists looking for oil deposits or shipping routes. We have explored less than 5% of the ocean floor in any detail. Entire landscapes remain unmapped, unseen, their contours known only through rough sonar pings. If the ruins of a pre-Ice Age civilization exist, they are most likely there, drowned and silted over, waiting in the dark. Some researchers have proposed systematic surveys of these submerged shelves, focusing on areas that would have been river valleys and coastlines 15,000 years ago. But funding is scarce, institutional resistance high, and the technological challenges immense. It is easier to excavate a desert than to excavate the sea, and so the ocean keeps its secrets and history remains incomplete. The Ice Age did not bury an empty world. It buried a world we have chosen not to remember, a world whose traces we have dismissed as anomalies, whose monuments we have dated to fit our preferred timeline, whose floods we have relegated to myth. But the ice remembers. Locked in the Greenland and Antarctic ice cores are layers of ash from fires that burned continents, isotopes from impacts that shattered the sky, pollen from plants that grew in climates long since vanished. The ice is an archive, a record of everything the Earth has endured, and it testifies to chaos, to catastrophe, to rapid changes that would have tested any civilization, ancient or modern. If humans were there, if they had built cities and temples and observatories, they would have watched the world end. Some would have fled to higher ground, to mountains and plateaus where the ice could not reach. Others would have taken to boats, riding out the floods, carrying with them whatever they could save, seeds, tools, knowledge, and when the waters receded and the ice retreated, they would have emerged into a world scoured clean, emptied of familiar landmarks, hostile and strange. They would have had to begin again, not from ignorance but from memory, fragments of what they had known, techniques half remembered, stories passed down through generations of survivors who no longer understood the world their ancestors had built, but tried desperately to rebuild it. Perhaps that is what Göbekli Tepe is. A monument to memory, a reconstruction of something older, an attempt by the survivors to preserve in stone what the ice had taken. Perhaps that is what all the ancient sites are, echoes of a lost world, built by people who were not inventing civilization but remembering it, piecing together from ruins and oral tradition a pale reflection of what had been. The world beneath the ice is still there, frozen in time, drowned in the deep. And until we excavate it, until we map the drowned coasts and dig beneath the glaciers, we will never know what we lost, or how many times we have had to begin again. In 1929, a group of scholars working in the Topkapi Palace in Istanbul discovered something that would haunt cartography for nearly a century. Among the palace archives, tucked between Ottoman administrative documents, lay a fragment of a map drawn on gazelle skin parchment, dated to 1513 and signed by an admiral named Piri Reis. The map showed the Atlantic Ocean, the western coast of Africa, the eastern coast of South America, and curiously the northern coast of Antarctica. This alone would be remarkable. Antarctica wasn't officially discovered until 1820. More than 300 years after Piri Reis drew his map. But what made the map truly impossible was the coastline it depicted. The Antarctic shore was drawn without ice, showing mountains, rivers, and coastal details that are currently buried under more than a mile of glacial sheet. The only way to see that coastline as Piri Reis drew it would be to map Antarctica as it existed before the ice covered it, which geological records suggest was at least 6,000 years ago, possibly much earlier. Piri Reis himself noted in the margins of his map that he had compiled it from about 20 source maps, some dating back to the time of Alexander the Great, others even older. He was not claiming to have discovered Antarctica. He was claiming to have copied it from maps that already existed, maps drawn by someone who had seen the continent when it was still free of ice. The Piri Reis map is not alone. In 1531, Oronteus Phineus, a French mathematician and cartographer, created a world map that also depicts Antarctica, this time showing the entire continent in striking detail. Mountain ranges, rivers, coastal features, all drawn with a level of accuracy that wouldn't be confirmed until the 1950s, when seismic surveys finally mapped the subglacial topography. The Oronteus Phineus map shows Antarctica not only ice-free, but split into two major landmasses separated by a waterway, a feature that modern geophysics has confirmed exists beneath the ice. The Transantarctic Mountains divide the continent into East and West Antarctica, and in a warmer climate, this division would indeed appear as Phineus drew it, with water flowing between the two halves. How could a 16th century cartographer working in France know this? He couldn't have. But he could have copied it from an earlier map, one drawn by someone who had actually seen Antarctica before the ice claimed it. Phineus, like Piri Reis, noted that his map was based on ancient sources, though he did not specify what those sources were or where they came from. They have since been lost, if they ever physically existed, leaving only these Renaissance copies as evidence that someone, somewhere, once mapped the world as it was in a much older epoch. The conventional explanation for these maps is that they are coincidences, that the cartographers were extrapolating or making educated guesses based on symmetry and the assumption that a southern continent must exist to balance the northern landmasses. But this explanation collapses under scrutiny. The level of detail is too specific, the geographic features too accurate, to be the result of guesswork. Modern researchers have compared the Piri Reis and Phineus maps to satellite data and sonar mapping of the bedrock beneath Antarctica's ice, and the correlations are undeniable. Coastal outlines match, river valleys align, mountain ranges appear where seismic data confirms they exist, hidden beneath ice that has covered them for millennia. These are not vague sketches or symbolic representations. These are maps drawn from observation, from surveys conducted when the land was visible, when the ice had not yet advanced, when Antarctica was habitable. And if those maps are accurate, then someone was there, surveying the coastlines, charting the rivers, mapping the interior at a time when conventional history insists no civilization existed anywhere on Earth. There are other maps, less famous but equally troubling. The Haji Ahmed map of 1559 shows the Pacific coast of North America with remarkable accuracy, including a land bridge connecting Siberia and Alaska, a feature that existed during the Ice Age when sea levels were lower, exposing Beringia, the corridor through which humans are believed to have first migrated to the Americas. But Beringia was submerged around 11,000 years ago when the glaciers melted and sea levels rose. How did Haji Ahmed know it had once existed? The Zeno map, published in Venice in 1558, depicts Greenland as it appears beneath its ice sheet, showing the island as an archipelago of smaller islands separated by waterways, a configuration that has only been confirmed in recent decades through ice-penetrating radar. Philippe Boitier, an 18th-century French geographer, published a map in 1737 showing Antarctica divided by a channel running through the center, decades before the continent was even discovered and centuries before the subglacial topography was mapped. Boitier's map was based, he claimed, on even older charts that had been preserved in French archives, though the originals have never been found. The pattern is consistent. Renaissance and early modern cartographers producing maps that contain information they could not possibly have acquired through their own exploration, information that can only have come from much older sources, sources that depicted the Earth as it was during or before the last ice age. The conventional academic response has been to dismiss these maps as anomalies, to attribute the accuracies to luck and the inaccuracies to incompetence, and to avoid the uncomfortable question they raise: who made the original maps? Because if the Piri Reis and Phineas maps are copies, if Boakye and Haji Ahmed were working from ancient sources, then somewhere in the distant past, there existed a maritime civilization capable of global navigation, capable of surveying coastlines with precision, capable of projecting those surveys onto maps using cartographic techniques that would not be rediscovered until the age of European exploration. This civilization would have needed ships capable of long ocean voyages, navigational tools to determine latitude and longitude, and the mathematical knowledge to translate three-dimensional geography onto two-dimensional parchment. They would have needed reasons to explore, economic or scientific motivations to chart distant lands. And they would have needed time, generations of accumulated data to produce maps of such accuracy. This is not the profile of a primitive culture. This is the profile of a civilization at least as advanced as the Phoenicians or the Polynesians, possibly more so. And yet, according to the orthodox timeline, no such civilization existed 1,000 or 15,000 years ago. Humanity was still in the Stone Age, still hunting mammoths and gathering berries, still millennia away from even conceiving of writing or cities or seafaring. But what if the timeline is wrong? What if the maps are not anomalies but evidence, fragments of a cartographic tradition that stretches back beyond the flood, beyond the ice, into an era we have written off as prehistory? The clues are there if one is willing to see them. Charles Hapgood, a historian and cartographer who spent years studying these ancient maps, proposed that they were remnants of a lost maritime civilization that existed during the last ice age and was destroyed when the ice melted and the seas rose. Hapgood's theory, presented in his book Maps of the Ancient Sea Kings, was ridiculed by mainstream academics, but found an unlikely supporter in Albert Einstein, who wrote a foreword to one of Hapgood's earlier works praising the rigor of his research. Hapgood argued that the maps showed knowledge of the entire globe, including Antarctica, the Arctic, and the Americas, and that this knowledge could only have been acquired by a civilization that had explored the world before the catastrophic climate changes at the end of the Ice Age wiped them out. The maps, in his view, were the last surviving records of that lost world, copied and recopied through the millennia, passed down from culture to culture, degraded and distorted with each iteration, but never entirely lost, waiting for a time when humanity had advanced enough to recognize what they were looking at. Modern geology lends some support to this possibility. We know that during the last glacial maximum, sea levels were 400 feet lower than they are today, exposing vast areas of continental shelf that are now submerged. These shelves were not barren ice fields, but habitable land, temperate and fertile, ideal for human settlement. We know that the climate was not uniformly frozen. There were ice-free corridors, coastal regions warmed by ocean currents, river valleys that remained habitable even as glaciers advanced inland. We know that anatomically modern humans existed throughout this period, that they possessed the same cognitive capabilities we have, the same capacity for innovation, organization, and long-term planning, and we know that when the ice melted, the floods were catastrophic. Rapid inundations that would have drowned coastal settlements, destroyed ports, and erased entire landscapes from the map. If a maritime culture had developed along those now drowned coasts, if they had built cities and harbors in the river deltas and estuaries that are now hundreds of feet underwater, almost all evidence of their existence would be gone, detectable only through underwater archaeology in regions we have not yet explored. The maps may be the only proof that remains, fragile copies of originals drawn when the world was a different shape, when Antarctica was green, when the shorelines stretched far beyond their current bounds, when someone, somewhere, was sailing the oceans and recording what they saw. The question is not whether the maps are accurate. Modern analysis has confirmed that they are. The question is how they came to be. If we accept that they depict the world as it was before the Ice Age ended, then we must also accept that someone was mapping it, someone with the means and the knowledge to explore globally, to survey coastlines, to measure distances, and to record their findings in a form durable enough to survive millennia of copying and transmission. This is not a small claim. It requires us to revise our understanding of human history, to acknowledge that the rise of civilization was not a singular event confined to Mesopotamia and Egypt, but a recurring pattern, a cycle of advancement and collapse that has played out multiple times over the span of human existence. The maps suggest that we are not the first to achieve global awareness, not the first to chart the Earth, not the first to rise to a level of sophistication we arrogantly assume is unique to our modern age. The maps suggest that we are simply the latest iteration, the most recent survivors of a cycle that has turned before and will turn again. And if that is true, then the greatest discovery waiting to be made is not in the stars or in the depths of space, but here on Earth, beneath the ice and beneath the waves, in the drowned cities and frozen ruins of the civilization that came before us, the civilization that drew the maps we can still read but have forgotten how to believe. There are stones standing in the desert that were not supposed to be moved by human hands. Not in 9600 BCE, not with stone tools and rope, not by people we have been taught to imagine as barely emerged from caves. Still learning the basics of agriculture, still decades away from inventing pottery. And yet the stones stand, arranged in perfect circles, carved with images of foxes and serpents and vultures, aligned to celestial points with a precision that implies generations of astronomical observation. Göbekli Tepe, in the highlands of southeastern Turkey, is the oldest known monumental architecture on Earth, predating Stonehenge by 6,000 years, predating the pyramids of Egypt by 7,000, predating even the earliest Sumerian cities. It should not exist. According to the evolutionary model of civilization, humans at this time were supposed to be nomadic hunter-gatherers, moving with the seasons, following game herds, living in temporary camps, leaving behind little more than flint blades and bone needles. They were not supposed to be capable of quarrying stones weighing 10 to 16 tons, transporting them hundreds of meters, carving them with elaborate reliefs, and erecting them in complex geometric arrangements that required planning, labor coordination, and an understanding of structural engineering. Yet they did, or rather, someone did. And the question that has haunted archaeology since the site's excavation began in 1995 is not just how they did it, but why, and what knowledge they possessed that we have not yet accounted for. Göbekli Tepe was not a settlement. No evidence of habitation has been found within the structures, no hearths, no trash pits, no signs of daily life. It was a ceremonial center, a place people traveled to from surrounding regions, gathering for purposes we can only infer from the symbolism carved into the stones. The pillars are T-shaped, some reaching 18 feet in height, arranged in circles with two taller pillars, standing at the center like guardians or focal points. The carvings depict animals, lions, boars, snakes, scorpions, birds, rendered with a naturalism and attention to detail that suggests intimate familiarity, not mythological abstraction, but observed reality. Some pillars show humanoid figures with their arms bent at the sides, as though the stones themselves are beings, silent watchers presiding over the ritual space. The site consists of multiple enclosures, at least 20 of which have been identified through ground-penetrating radar, though only a fraction have been excavated. Each enclosure seems to have been deliberately buried after a period of use, filled in with rubble and sediment, then covered over and built upon again, creating layers of construction that span centuries. Why bury a monument of such effort and significance? Some archaeologists suggest it was ritual closure, a way of sealing sacred spaces when their purpose had been fulfilled. Others wonder if it was preservation, an attempt to hide the site from some approaching danger, to protect it from destruction by encasing it in earth. What makes Göbekli Tepe even more enigmatic is its sudden appearance and subsequent decline. The site was built, used and buried over a period of roughly 2,000 years, from approximately 9600 to 7600 BCE. Then construction stopped. The circular enclosures gave way to smaller rectangular structures of lesser ambition and skill, as though the knowledge required to build the earlier phases had been lost or abandoned. By 7000 BCE, the site was largely deserted, its monumental architecture left to erode beneath accumulating soil. This pattern, initial sophistication followed by decline, contradicts the expected trajectory of cultural development, which should show gradual improvement over time as techniques are refined and knowledge accumulates. Instead, Göbekli Tepe suggests devolution, a peak of capability at the beginning that later generations could not maintain. It is as if the builders of the earliest enclosures were working from a template, following a design handed down from an even older tradition. And as that knowledge faded from memory, so did their ability to replicate it. The site does not mark the invention of monumental architecture. It marks its resurgence, a moment when post-catastrophe survivors, carrying fragments of lost knowledge, attempted to rebuild what had been destroyed. Göbekli Tepe is not alone. Across the world, megalithic structures of inexplicable antiquity and sophistication are being re-evaluated, their dates pushed back, their purposes reconsidered. In Indonesia, Gunung Padang rises from the jungle like a terraced pyramid, its surface covered with columnar basalt blocks arranged in geometric patterns. For decades, it was assumed to be a natural hill with some later human modification, a temple built atop a geological formation. But in 2010, geologists using ground-penetrating radar, seismic tomography, and core drilling discovered that the structure was far more extensive than its surface suggested. Beneath the visible layers lie older constructions, chambers and walls built from shaped stone. Extending deep into the hillside, radiocarbon dating of organic material found in the deeper layers returned dates as old as 2,000 years, deep into the last ice age. Mainstream archaeologists rejected these findings, calling them impossible, arguing that the dated material could have infiltrated the layers through natural processes. But the geophysical data persists, showing unmistakable geometric patterns, right angles, voids that suggest intentional construction, not random geology. If the early dates are correct, Gunung Padang would be the oldest known pyramid on Earth, built at a time when humans were not supposed to be building anything at all. In Egypt, the Great Sphinx crouches at the edge of the Giza Plateau, its weathered body facing the rising sun, its origins lost to time and myth. Conventional Egyptology dates the Sphinx to the reign of Pharaoh Khafra, around 2500 BCE, based on the proximity of Khafra's pyramid and the stylistic similarity of the Sphinx's face to other Old Kingdom sculptures. But geologists examining the Sphinx have identified weathering patterns on its body that are inconsistent with wind and sand erosion, the dominant forces in the Egyptian desert. Instead, the vertical fissures and undulating surface suggest prolonged exposure to water, to rainfall, a weathering process that would require a much wetter climate than Egypt has experienced in recorded history. The last period of significant rainfall in the region ended around 20,000 years ago, at the close of the African humid period, when the Sahara was green and the Nile flowed through landscapes vastly different from the arid desert we see today. If the water erosion hypothesis is correct, the Sphinx must predate the pharaohs by thousands of years, carved when Egypt was wet, when the Giza Plateau overlooked not desert, but savanna. The face may have been recarved in dynastic times, the body repaired and refurbished, but the original structure, the leonine form, would belong to an earlier epoch, to a civilization capable of monumental sculpture long before Egypt as we know it existed. These are not isolated anomalies, but part of a global pattern. In Malta, the megalithic temples of Gantijar and Hagar Kim, built from massive limestone blocks, some weighing over 50 tons, date to 3600 BCE, making them older than the pyramids and contemporary with the earliest phases of Sumerian civilization. Yet Malta at this time was supposedly inhabited by simple farming communities, not societies capable of quarrying, transporting and assembling stones of such size. In Peru, the walls of Sacsayhuaman near Cusco display polygonal masonry so precise that a knife blade cannot fit between the stones, fitted together without mortar in irregular interlocking shapes that defy the limitations of Bronze Age or even Iron Age tools. The Inca, who occupied the site in the 15th century, claimed they did not build it, that it was already ancient when their ancestors arrived, built by a race of giants, or by the gods themselves. Modern engineers examining the site have struggled to explain how the stones were shaped and fitted with such precision, proposing everything from bronze chisels to extraterrestrial assistance, but no consensus has emerged. What is clear is that someone, at some point, possessed techniques of stoneworking that have been lost and not recovered. In Lebanon, the ruins of Baalbek contain the largest cut stones ever used in construction, the Trilithon, 3 blocks each, weighing approximately 800 tons, fitted seamlessly into the foundation of the Temple of Jupiter. The Roman temple sits atop these blocks, but the Romans did not cut or place them. Roman construction techniques, well documented and understood, could not have moved stones of this size. The blocks were already there when the Romans arrived, part of an older structure whose origin they did not record, or perhaps did not know. Local legend attributes the construction to the biblical giants, the Nephilim, or to Cain, the first murderer, who was said to have built the city as penance. Below the Trilithon lies an even larger block, the Stone of the Pregnant Woman, weighing over 1,000 tons, still partially attached to the bedrock of the quarry a quarter-mile away. It was shaped, prepared for transport, but never moved, abandoned as though the builders had been interrupted mid-task, called away by some catastrophe they could not return from. The scale of these stones defies not just ancient capability, but modern capability. We do not have cranes that can lift 1,000 tons. We do not have vehicles that can transport such loads. And yet the stones exist, cut and placed, with precision, silent testimony to an engineering tradition we have not inherited. The megalithic whisper is not loud. It does not announce itself with inscriptions or explanations. It speaks through silence, through the mute presence of stones too large, too precisely placed, too astronomically aligned to be dismissed as primitive ritual or accidental achievement. It speaks through the dates that keep getting pushed back, the constructions that keep appearing earlier and earlier in the timeline, challenging the neat progression from simple to complex that archaeology relies upon. And it speaks through the recurring theme of forgetting, the way site after site shows evidence of initial sophistication followed by decline, as though the builders were working from inherited knowledge that later generations could not fully understand or replicate. Göbekli Tepe buried and abandoned. Gunung Padang's oldest layers sealed beneath later cruder work. The Sphinx weathered by rains that stopped falling 10,000 years ago. Baalbek's megalithic foundation supporting temples built by people who did not know where the stones came from. These are not the marks of invention. These are the marks of inheritance, of reconstruction, of survivors attempting to preserve what they could of a knowledge that was already fading. The stones whisper what the texts cannot say, what the flood washed away, what the ice buried and crushed. They whisper that we are not the first to build, not the first to measure the heavens, not the first to shape the world according to our will. They whisper that the Ice Age did not begin with emptiness, but ended with it, that what we call the dawn of civilization was actually a pale sunrise after a long night, and that somewhere beneath the stones, beneath the forgetting, lies the memory of what came before. There is a story told in 638 different cultures, spread across every inhabited continent, separated by oceans and mountains and thousands of miles, yet all telling the same tale. The world drowned. Water rose and covered the land. The sky opened and did not close. The sea climbed the mountains. Humanity was erased, save for a few who were warned, who built vessels, who rode out the storm and emerged into a world scoured clean. The details differ. The names of the survivors, the animals they saved, the gods who sent the flood or tried to prevent it. But the structure is identical, the sequence of events unchanging. There was a world before. There was a catastrophe. There was survival. There was rebuilding. We call these stories myths, relegating them to the realm of religious allegory and primitive superstition, as though ancient peoples across the globe independently invented the same fictional disaster to explain their anxieties about divine wrath. But what if they were not inventing? What if they were remembering? What if the flood myths are not myths at all, but oral archives, the only records that survived of an event so catastrophic that it reset human civilization, drowning the world that was, and forcing the survivors to begin again with nothing but memory? The Sumerian version is the oldest written account, the Epic of Ziusudra, fragments of which date to around 2000 BCE, but describe events from much earlier. The Akkadian Atrahasis epic, slightly later, tells the same story in greater detail. The gods grow weary of humanity's noise and decree destruction through flood. Enki, the god of wisdom, warns Atrahasis, instructs him to build a boat sealed with bitumen, to bring aboard his family and the seed of all living things. The storm comes, lasting 7 days and 7 nights, so terrible that even the gods cower in fear. When the waters recede, Atrahasis offers sacrifice, and the gods, smelling the sweet savor, regret their decision and promise never to destroy humanity so completely again. The Hebrew Bible's account of Noah is nearly identical, transplanted from Mesopotamia to the Levant with theological modifications, but retaining the same core: a righteous man, a boat, animals in pairs, a dove released to find land, a covenant established after the waters fall. The Greeks told of Deucalion and Pyrrha, the sole survivors of a flood sent by Zeus, who repopulated the earth by throwing stones over their shoulders, stones that became people. In India, the Satapatha Brahmana describes Manu, warned by a fish that grew to enormous size, who built a ship and survived the deluge that drowned the world. In Chinese mythology, Gun and Yu battle the Great Flood, building dikes and channels to contain the waters. The Aztecs speak of the fourth sun, ending in flood, the world washed away before the current age began. The Maori of New Zealand tell of a canoe that survived rising waters. The Algonquin tribes of North America recount Nanabojo escaping on a raft. The Aboriginal Australians speak of the Dreamtime flood. The list goes on, culture after culture, each preserving the same memory. For centuries, scholars explained this convergence through diffusion, the idea that the story originated in one place, probably Mesopotamia, and spread through trade and migration, carried by travelers who adapted it to local contexts. But diffusion cannot account for the geographic distribution. Flood myths exist in cultures that had no contact with Mesopotamia, no access to cuneiform tablets or oral traditions from the Fertile Crescent. The indigenous peoples of the Americas, isolated from the Old World for at least 12,000 years, tell flood stories indistinguishable in structure from those of the Middle East. The same is true for Pacific Islanders, for Sub-Saharan Africans, for Australian Aboriginals. Either every human culture independently invented the same catastrophe narrative, a staggering coincidence, or they are all remembering the same event, an actual flood so vast and so devastating that it entered the collective memory of humanity, passed down through oral tradition for millennia until it could be written down. The second explanation is more parsimonious. It requires only one event, not 638 independent inventions, and geology increasingly supports it. The end of the last ice age was not a gentle thaw, but a series of catastrophic meltwaters, sudden releases of glacial lakes, rapid sea level rises that redrew the map of the world. Around 14,600 years ago, Meltwater Pulse 1A raised global sea levels by 50 feet in less than 500 years, a rate of more than 1 foot per decade. To people living on the coasts, this would have been apocalyptic. Shorelines that had been stable for generations suddenly began advancing inland, swallowing fishing villages, harbors, river deltas, fertile plains. The sea did not creep forward. It surged, driven by the collapse of ice dams and the sudden drainage of immense glacial lakes that had been held back by retreating ice sheets. Lake Agassiz, which covered much of central North America, contained more water than all the modern Great Lakes combined. When its ice dam failed around 13,000 years ago, the lake drained catastrophically into the North Atlantic, pouring so much fresh water into the ocean that it disrupted the thermohaline circulation, the global current system that regulates climate. The result was the Younger Dryas, a sudden return to glacial conditions that lasted over 1,000 years, plunging the warming world back into cold and halting the progress of early agricultural societies that had begun to emerge. When the Younger Dryas ended around 1600 years ago, the melt resumed with even greater violence. Sea levels rose another 300 feet over the next few millennia, drowning an estimated 25 million square kilometers of land, an area larger than North America. The Persian Gulf, which had been a fertile river valley, became a sea. The Mediterranean, swollen by meltwater, breached the Bosphorus and flooded the Black Sea basin in what may have been a single catastrophic inundation, the water pouring through the narrow strait with the force of 200 Niagara Falls, raising the Black Sea's level by hundreds of feet and drowning thousands of square miles of inhabited land. Marine archaeologists have found evidence of submerged settlements along the ancient coastline, structures now 300 feet below the surface, preserved in the anoxic depths where oxygen does not penetrate and decay cannot occur. The flooding of the Black Sea is dated to around 7,500 years ago, well within the range of human memory and oral tradition, and it corresponds to the timing of flood myths in the Near East and Mediterranean. This was not allegory. This was history, catastrophic and sudden, traumatic enough to be remembered and retold for thousands of years. But the Black Sea flood, dramatic as it was localized. The global flood myths suggest something more widespread, something that affected coastlines everywhere, not just in one region. And here the geology becomes even more compelling. At the end of the Pleistocene, the Earth was not just melting, it was destabilizing. The massive weight of the ice sheets, some more than 2 miles thick, had pressed down on the continents, deforming the crust. As the ice melted and the weight lifted, the crust rebounded, a process called isostatic rebound, which triggered earthquakes and volcanic eruptions along fault lines that had been compressed for millennia. The sudden redistribution of weight, billions of tons of ice turning to water and flowing into the oceans, shifted the planet's rotational balance, possibly contributing to changes in the Earth's axial tilt and orbital parameters. There is evidence, controversial but persistent, that around 2,800 years ago, fragments of a disintegrating comet struck the Earth, igniting wildfires across North America, Europe and Asia, vaporizing ice sheets and generating shockwaves that would have been felt globally. The Younger Dryas impact hypothesis, as it is called, is supported by the presence of nanodiamonds, iridium and platinum anomalies in sediment layers dating to this period, along with widespread deposits of carbon spherules and melt glass, materials that form under extreme heat. Whether the impact was a single event or a series of airbursts, the effect would have been apocalyptic. Fires, floods, climate collapse, and the rapid extinction of megafauna across the Americas and Eurasia. For any humans living through this period, the experience would have been indistinguishable from the end of the world. The sky burning, the ice melting, the seas rising, the ground shaking, the climate lurching from warm to cold and back again within a single human lifetime. Coastal settlements would have been inundated, river valleys would have flooded, lakes would have drained or overflowed. The landmarks by which people navigated their world, the shape of the coastline, the course of rivers, the extent of forests, would have changed beyond recognition. Survival would have required flight, migration to higher ground, to mountains and plateaus where the waters could not reach. And in the aftermath, when the waters finally stabilized and the climate settled into the Holocene warmth we still enjoy, the survivors would have told stories. Stories of the world that was, the world before the flood, the world that drowned. They would have told these stories to their children, and their children would have told them to theirs, and over millennia the details would blur, the names would change, the gods would replace the geology, but the core would remain. There was a world, there was water, there was loss, there was survival. The flood myths are not primitive fantasies. They are compressed data, oral records of a real event, preserved through the only medium available to pre-literate cultures, storytelling, and the fact that 638 cultures remember it, in regions that span the globe, suggests that the event was not local but global, or at least widespread enough that every surviving population carried the memory forward. The deluge remembers what history forgot, because history, as we conceive it, begins after the flood, after the waters receded and the survivors began to rebuild. The antediluvian world, the world before, left almost no physical trace. Its cities drowned, its monuments eroded, its people scattered or dead. But it left a narrative trace, a memory encoded in myth, in sacred texts, in stories told around fires for 1,000 years. We have dismissed these stories because we assume ancient peoples were incapable of preserving accurate information, that oral tradition degrades into fantasy within a few generations. But the Aboriginal Australians have oral traditions describing the flooding of coastal lands that can be correlated with sea level rise 1,000 years ago. The Salish peoples of the Pacific Northwest tell stories of eruptions and floods that match geological records of volcanic events 7,000 years ago. Memory, when embedded in ritual and passed through structured oral tradition, is more durable than we give it credit for. The flood myths are not distortions. They are archives, the last testimony of the people who watched the Ice Age end and the world drown, who survived to tell the tale and made sure, through repetition and sacredness, that the tale would not be forgotten. History may have forgotten them, but the deluge remembers, and it speaks through their voices, through stories that refuse to die, waiting for us to stop calling them myths and start calling them what they are. Witness testimony from the edge of catastrophe. There is a motion in the heavens so slow that a human lifetime cannot perceive it, a drift so gradual that generations pass without noticing the sky has changed. It is called precession, the wobble of Earth's axis as it rotates, a gyroscopic movement that takes approximately 26,000 years to complete one full cycle. During this great turning, the position of the stars shifts against the horizon. The North Star changes. The constellations of the zodiac, those 12 segments through which the sun appears to move over the course of a year, slowly drift backward through the calendar. The spring equinox, which currently occurs when the sun rises in Pisces, will eventually shift into Aquarius, then Capricorn, cycling through all 12 signs over the span of the great year. This phenomenon, invisible to casual observation, imperceptible within a single human life, was unknown to Western science until Hipparchus discovered it in the 2nd century BCE, or so the story goes. But Hipparchus did not discover precession, he inherited it. The Babylonians knew of it, tracking the slow drift of the equinoxes across centuries of recorded observation, and the Babylonians inherited it from the Sumerians, who wrote of celestial cycles spanning thousands of years, with a precision that implies not discovery, but transmission. Someone, long before Sumer, had watched the stars long enough to know that the sky was turning, that the heavens were a clock measuring time in units far beyond the mortal span. Someone had been observing for millennia. The zodiac itself is a map of precession, a calendar designed to track the great year. It divides the ecliptic, the apparent path of the sun through the sky, into 12 equal segments, each corresponding to roughly 2160 years of precessional movement. The age of Taurus, when the spring equinox rose in the constellation of the Bull, lasted from approximately 4500 to 2300 BCE, the era of the first Egyptian dynasties, whose iconography is dominated by bull imagery. The age of Aries followed, from 2300 to 150 BCE, the time of the ram-headed gods, of Moses and the golden calf, of sacrifice and fire. The age of Pisces, the fish, began around the time of Christ and continues into the present, marked by early Christian use of the fish symbol. The progression is deliberate, encoded in religious symbolism across cultures that supposedly had no contact. The Egyptians, the Mesopotamians, the Hebrews, the Hindus, all organized their cosmologies around the same 12-fold division, all tracked the same precessional ages, all seemed to know that the heavens were cycling through a pattern that would not repeat within historical memory, but only across spans of deep time. How did they know? The standard explanation is that they observed the stars for centuries, noticed small discrepancies in their rising and setting points, and extrapolated the larger pattern. But this assumes institutional continuity, unbroken chains of observation and record-keeping stretching back thousands of years. And for cultures emerging from the supposed darkness of prehistory, this seems implausible, unless they were not emerging. Unless they were remembering. In India, the Vedic texts describe yugas, cosmic ages measured in thousands and millions of years, cycles within cycles that govern the rise and fall of civilization. The current age, the Kali Yuga, is said to have begun in 3102 BCE and will last 442,000 years before giving way to a new golden age. The numbers are staggering, far beyond the scale of recorded history, yet they are not random. They correspond to precessional mathematics, to subdivisions of the great year. A full precession of 25920 years, divided into 12 ages of 2160 years each, further subdivided into smaller units, produces numbers that match the Yuga system with eerie precision. The Vedic astronomers were not guessing. They were calculating, using a framework that required knowledge of the precession cycle, knowledge that could only have been acquired through millennia of observation or inherited from a source that had already completed that observation. The Vedas themselves claim to be timeless, eternal knowledge revealed at the beginning of each cycle, not invented by humans, but remembered, recovered from the cosmic memory after each dissolution of the world. This is not the language of discovery. This is the language of restoration. The Egyptians encoded precession into the alignment of their monuments. The 3 pyramids of Giza, according to some researchers, mirror the positions of the 3 stars in Orion's belt as they appeared around 10500 BCE. not when the pyramids were built, but millennia earlier, as though the structures were commemorating a celestial configuration from a much older epoch. The Sphinx, if the water erosion hypothesis is correct, may also date to this period, carved when the constellation Leo rose on the spring equinox, the age of the lion, a time when the Sphinx, a lion's body with a human head, would have faced its celestial counterpart at dawn. These alignments suggest that the builders were not merely observing the sky as it was, but as it had been, deliberately encoding processional knowledge into stone, creating monuments that would survive long enough to testify to their understanding of cycles far longer than any empire or dynasty. The precision required to execute such alignments is staggering. Modern astronomers using computer models to reconstruct the ancient sky have confirmed that the Giza Plateau does align with Orion, circa 2500 BCE, a date that precedes the accepted construction of the pyramids by over 7,000 years. Either the alignment is coincidence, or the pyramids were planned according to knowledge inherited from an earlier time, a time when astronomers had already mapped the heavens across precessional epochs. The Maya possessed a similar obsession with deep time. Their long count calendar, which begins in 3114 BCE and measures time in units called baktuns, each lasting 4,000 days, tracks cycles spanning thousands of years. The completion of 13 baktuns, around 5,125 years, marks a significant transition, a turning of the age. But the Maya also calculated much longer cycles, the Great Cycle of 26,000 years, which corresponds almost exactly to one full precession of the equinoxes. They tracked the movements of Venus with such precision that their calculations, recorded in the Dresden Codex, differ from modern measurements by only fractions of a day over centuries. They observed Jupiter, Mars, and the Moon, charting their synodic periods, the time it takes for a planet to return to the same position relative to Earth and the Sun, with accuracy that should have required instruments they did not possess. How did they do it? The conventional answer is patient observation over generations, but the Maya claim, as the Vedic texts do, that their knowledge was given to them by the gods, by Quetzalcoatl and Kukulkan, divine teachers who appeared after a great flood and instructed humanity in the arts of civilization. The Maya were not inventing astronomy. They were preserving it, copying and recalculating tables inherited from an older tradition, maintaining knowledge whose origin had been lost to time. The alignment of sacred sites across the globe to precessional epochs cannot be coincidence. Angkor Wat in Cambodia, built in the 12th century CE, is aligned to the spring equinox as it occurred in the Age of Aries, thousands of years before the temple was constructed, as though the builders were commemorating an earlier astronomical configuration. Tiwanaku in Bolivia, with its massive stone structures and precise solar alignments, has astronomical features that some researchers argue are calibrated to a sky much older than the accepted construction date. The Nabta Playa stone circle in the Egyptian desert, dated to around 7,000 years ago, contains alignments to stars that are accurate for that period, but also seem to reference precessional positions from earlier epochs. Again and again, the pattern emerges, ancient sites encoding astronomical knowledge that predates their construction, as though the builders were working from blueprints handed down from a civilization that had already completed the observations, already mapped the cycles, already understood that the heavens were a clock measuring time in units of 2,000, 26,000, even 43,000 years. This is not the work of isolated cultures stumbling independently toward the same conclusions. This is the work of a shared tradition, a global inheritance of astronomical knowledge that was old when Sumer was young. The sophistication of this knowledge is difficult to overstate. To recognize precession, one must observe the sky for at least several centuries, tracking the positions of stars at the same time each year, noting the gradual shift and then extrapolating the full cycle. To encode that knowledge into calendars and monuments requires mathematics, long-term planning, and institutional continuity. The cultures we credit with early astronomy, the Babylonians, the Egyptians, the Maya, all appeared relatively late in human history, emerging after the Ice Age, after the floods, after the Younger Dryas. Yet they possessed astronomical knowledge that implies observation spanning millennia. Observation that could not have been conducted during their own historical periods. The logical conclusion is that they inherited this knowledge from predecessors, from astronomers who lived during the Ice Age or earlier, who watched the stars through multiple precessional ages, who tracked the slow turning of the heavens across thousands of years and recorded their findings in a form durable enough to survive the catastrophes that ended their world. Those records may have been oral, encoded in myth and ritual. They may have been architectural, embedded in the alignment of megaliths and temples, or they may have been written, inscribed on materials that have since dissolved, leaving only copies made by later cultures who no longer fully understood what they were preserving. The lost astronomers are nameless. We do not know where they lived, what language they spoke, what cities they built. But we know they existed, because the knowledge they accumulated is still here, embedded in the calendars we use, the zodiacs we reference, the monuments that align to stars in configurations that no longer exist, but once did, long ago, when the ice was thick and the coasts were far from where they are now. They watched the sky when the world was different, when the North Star was Vega instead of Polaris, when the spring equinox rose in Leo or Virgo, when Orion climbed the sky at angles we can only reconstruct with computers. They knew the great year, the 26,000-year cycle, and they knew it because they had seen it turn, or because their ancestors had seen it and passed the knowledge down through chains of transmission we can no longer trace. The sky was their archive, more durable than any clay tablet, more reliable than any oral tradition, because the stars do not lie. The stars repeat, cycling through the same patterns, and if you watch long enough, you learn the rhythm, you recognize the return. The lost astronomers left us that rhythm, encoded in 12 signs in precessional ages, in temples that still point to where the stars once were. We call them primitive, but they knew what we are only now rediscovering, that time is not linear, that history is cyclical, that the heavens turn and return, and that those who watch long enough will see the sky come back to where it began, signaling the end of one age and the beginning of another. The question is not whether they knew. The question is how long they had been watching and what world they were living in when they first looked up and began to count the stars. There is a phrase that appears in ancient texts from civilizations separated by oceans and millennia, a phrase so specific and so repeated that it cannot be coincidence. They speak of a time before the flood, an age when the world was different, when knowledge was greater, when beings of immense wisdom walked the earth and taught humanity the arts of civilization. The Sumerians called it the antediluvian period, the era of the 8 kings who ruled for impossible spans before the waters swept over. The Egyptians spoke of Zep Tepi, the first time, when the gods themselves governed from the banks of the Nile, building the original temples that later pharaohs could only restore. The Hebrews remembered the Nephilim, giants who lived before the flood and possessed knowledge forbidden to ordinary men. The Vedic texts describe previous yugas, golden ages of enlightenment that ended in cataclysm, forcing humanity to rebuild from fragments. The Greeks told of Atlantis, Plato's island civilization that sank beneath the waves in a single day and night, its advanced culture lost forever. These are not independent inventions. They are variations of the same testimony, accounts of a world that existed before recorded history, a world more advanced than what followed, a world destroyed so completely that only memory and myth preserve its existence. We dismiss them as legends because we cannot reconcile them with the archaeological record. But what if the problem is not the texts, but our interpretation? What if the antediluvian archive is real, scattered across cultures, encoded in stories we have refused to take seriously? Plato's account of Atlantis, written in the dialogues Timaeus and Critias around 360 BCE, is the most famous of these references. He describes a powerful island nation located beyond the Pillars of Hercules, in the Atlantic Ocean, ruled by kings descended from Poseidon, possessing advanced technology, vast fleets, and dominion over lands stretching into Europe and Africa. Atlantis waged war against the ancient Athenians, but before the conflict could be resolved, the island was struck by earthquakes and floods and sank into the sea, disappearing in a single catastrophic event. Plato claims the story was passed down through his ancestor Solon, who heard it from Egyptian priests in the Temple of Sais, who said the events occurred 9,000 years before Solon's time, placing the destruction of Atlantis around 9600 BCE, the exact period when the Ice Age was ending, when sea levels were rising, when coastlines were being redrawn by meltwater pulses. Scholars have debated for centuries whether Plato intended Atlantis as allegory or history, but his account contains details too specific to be pure invention. The circular layout of the city, the canal system, the description of the island's resources and geography, the timeline that places its destruction at the end of the Pleistocene. And the Egyptian priests told Solon something else, something that echoes across every flood tradition, that the world has been destroyed many times by fire and by water, and that each time a few survive to rebuild, forgetting most of what came before. The Egyptian Edfu texts, inscribed on the walls of the Temple of Horus at Edfu, tell a similar story, but with more detail and less ambiguity. These texts, dating to the Ptolemaic period but claiming to preserve knowledge from much earlier sources, describe the island of creation, a primordial landmass where the gods first established civilization. The texts refer to the Shemsu-Hor, the followers of Horus, a race of divine or semi-divine beings who possessed the knowledge of the gods and who built the first temples in Egypt not during the dynastic period but long before, in Zep-Tepi, the first time. These original temples, the texts say, were later destroyed by a great flood, and the surviving Shemsu-Hor dedicated themselves to rebuilding what had been lost, traveling across Egypt to re-establish sacred sites on the foundations of the drowned originals. The Edfu texts describe the Shemsu-Hor as guardians of knowledge, preservers of the sacred sciences, astronomy, mathematics, architecture, medicine, which they taught to the early Egyptians. The texts even provide measurements and architectural plans for the original temples, as though the scribes were working from blueprints that had survived the catastrophe. This is not mythology in the sense of invented fiction. This is mythology in the sense of preserved history, oral records formalized into written form, accounts of real events distorted by time but not entirely obscured. In Hindu tradition, the concept of cyclical time dominates. The Puranas describe the universe moving through endless cycles of creation and dissolution, each cycle lasting billions of years, subdivided into 4 yugas or ages: the Satya Yuga, the golden age of truth and enlightenment; the Treta Yuga, where decline begins; the Dvapara Yuga, where darkness increases; and the Kali Yuga, the current age of strife and ignorance. At the end of each cycle, the world is destroyed by fire or flood, and a new cycle begins. But within this cosmological framework lies a specific claim that in previous cycles humanity achieved great heights of knowledge and power, building cities and mastering technologies that were lost when the cycle turned. The Mahabharata and Ramayana, epic texts that blend history and myth, describe flying machines called vimanas, advanced weapons that sound disturbingly like nuclear devices, cities with planned grids and sophisticated infrastructure. Skeptics dismiss these as fantasy, but the descriptions are precise, technical, often including measurements and materials that suggest the authors were describing real objects, either from direct observation or from inherited accounts. The texts also describe a great war followed by a cataclysm that destroyed the old world, scattering the survivors and forcing them to rebuild with reduced knowledge. This is the same pattern: advanced civilization, catastrophe, survival, reconstruction, memory preserved in stories that later generations would interpret as myth. The Sumerian king list, with its antediluvian rulers reigning for tens of thousands of years, is another fragment of the archive. Conventional scholars interpret the impossible lifespans as symbolic, representing dynasties or astronomical cycles rather than individuals. But the Sumerians themselves made no such distinction. They listed these kings alongside historical rulers in the same format, using the same language, treating the antediluvian period as continuous with the post-diluvian. The text states plainly, after kingship descended from heaven, kingship was in Eridu. In Eridu, Alulim became king. He ruled for 800 years. Then the flood. Then kingship descended again, and the reigns become human, hundreds of years, then decades. The shift is abrupt and absolute, as though the flood did not merely destroy cities, but altered the nature of time itself, or at least the way humans experienced it. Some researchers have proposed that the numbers are encoded data, that the reigns represent precessional ages or generational counts compressed into single figures. Others suggest the antediluvian kings were not individuals, but titles, positions held by successive leaders whose tenures were aggregated into totals that only seem impossible. But the simplest reading, the one the Sumerians themselves seem to intend, is that these were remembered as actual rulers from a time so remote that memory could no longer accurately preserve the details, only the sense of immense age, of a world that lasted far longer than the one that came after. The persistence of these accounts across unconnected cultures suggests a common source, a shared memory of an actual antediluvian world. The details vary because the memory has fragmented, passed through different languages, different religious frameworks, different oral traditions, each adding its own interpretations and distortions. But the core remains. There was a world before. It was advanced. It was destroyed by water, and some knowledge survived. The antediluvian archive is not a single text or monument, but a distributed database. Pieces of the same historical record scattered across the globe, preserved in myths, in king lists, in temple inscriptions, in oral traditions that predate writing. Assembling this archive requires reading across cultures, comparing flood myths, tracking the transmission of astronomical and architectural knowledge, identifying patterns that repeat too consistently to be independent invention. It requires treating ancient testimony not as primitive fantasy, but as garbled history, signal mixed with noise, data corrupted by transmission errors, but still recoverable if one knows how to filter and decode. Some researchers have attempted this reconstruction. Graham Hancock, in his book Fingerprints of the Gods, argued that a global maritime civilization existed during the last ice age, that it was destroyed by the cataclysms at the end of the Younger Dryas, and that survivors spread across the world, teaching remnant populations the knowledge needed to rebuild. He pointed to the flood myths, the megalithic sites, the astronomical alignments, the maps showing ice-free Antarctica, all as evidence of this lost civilization. Mainstream academia rejected his conclusions as speculative, but his method, comparative mythology, cross-cultural analysis, integration of geology and archaeology, was sound. The evidence he compiled does not prove a lost civilization, but it raises questions that conventional history struggles to answer. Why do so many cultures remember a flood? Why do their myths describe teachers appearing after the deluge to instruct survivors? Why does advanced knowledge appear suddenly in the archaeological record with no visible antecedents? The answers offered by orthodoxy, Independent invention, coincidence, gradual development obscured by incomplete evidence, are increasingly unsatisfying. The alternative, that humanity has been through this cycle before, that civilization rose and fell during the Ice Age, leaving only fragments that we have misinterpreted or ignored, fits the data more comfortably. The antediluvian archive is still being written, or rather, still being recovered. Every new discovery, a submerged structure off the coast of India, a megalithic site in Turkey dated to 9600 BCE, a flood layer in Mesopotamian stratigraphy, an ancient map showing coastlines as they were 12,000 years ago, adds another piece to the puzzle. Each piece alone is ambiguous, explainable through conventional means, but together they form a pattern, a coherent narrative that the texts have been telling us all along. That history is older and stranger than we have been taught, that the Ice Age was not a time of emptiness but of loss, and that what we call the beginning of civilization was actually a resurgence, a slow, painful recovery from catastrophe. The antediluvian world is not a fantasy. It is a hypothesis, testable and falsifiable, supported by converging lines of evidence from mythology, geology, archaeology, and astronomy. We have not yet proven it existed, but we have not disproven it either. And the archive waits. In the texts we call myths, in the ruins we call anomalies, in the memories encoded in stories too persistent to die, whispering the same message across cultures and centuries. There was a world before this one, and if we listen carefully, if we read between the lines of legend and stone, we might still hear it speaking. There is a continent at the bottom of the world that no humans saw until 1820, a landmass larger than Europe, buried beneath ice so thick that its weight has pressed the bedrock more than half a mile below sea level. Antarctica is the coldest, driest, most inhospitable place on Earth, a frozen desert where temperatures plunge to minus 130 degrees Fahrenheit, where winds scream at 200 miles per hour, where nothing grows and almost nothing lives. It has been this way for millions of years, we are told, locked in ice since long before humans walked upright. A continent untouched by civilization, irrelevant to human history. And yet, there are maps. Maps drawn centuries before Antarctica was discovered, showing its coastline with accuracy that should be impossible, depicting rivers and mountains that exist only beneath the ice, hidden from view, invisible to the cartographers of the Renaissance, who somehow knew they were there. The maps show Antarctica as it would appear if the ice were gone, as it might have appeared 6,000 or 12,000 years ago before the glaciers covered it, when the continent was still habitable, when its shores could be surveyed, when someone was there to draw the lines. The question of Antarctica is not whether it was mapped. The question is who mapped it and when, and what they were doing there in an age when no civilization was supposed to exist. The Peary Race map of 1513 is the most famous, but it is not alone. The Orontius Phineus map of 1531 shows the entire continent in detail, its outline matching modern surveys with disturbing precision. The continent is depicted ice-free, with mountain ranges running through the interior, rivers flowing to the coast, bays and inlets that correspond to features now hidden beneath thousands of feet of ice. In 1737, Philippe Boichet published a map showing Antarctica divided into two land masses separated by a channel of water, a configuration that was not confirmed until the 20th century, when seismic surveys revealed that beneath the ice, Antarctica is indeed split by the Transantarctic Mountains, and that if the ice were removed, seawater would flood the gap, creating the exact division Boichet depicted. How did he know? He claimed to be working from older sources, charts that had been preserved in French archives but whose origins were lost. The same explanation appears again and again. Renaissance cartographers were not discovering Antarctica but copying it from ancient maps. Maps that showed the continent as it was in a much earlier epoch, maps that someone long ago had drawn from direct observation. Modern science confirms that Antarctica was not always frozen. Geological and paleoclimatic data show that as recently as 34 million years ago, Antarctica was warm, covered in forests, inhabited by fauna that could not survive in ice. But that was long before humans existed, irrelevant to the question of ancient maps. More intriguing is the period between 15,000 and 6,000 years ago, when global temperatures were rising, ice sheets were retreating, and parts of Antarctica, particularly the coastal regions, may have been ice-free or at least accessible. Core samples taken from the Ross Sea reveal sediment deposited by rivers flowing from ice-free land around 6,000 years ago, suggesting that portions of the continent were exposed much more recently than mainstream geology typically acknowledges. If Antarctica had ice-free coasts during this period, it would have been possible, in theory, for maritime explorers to reach it, to survey its shores, to map its rivers and mountains before the returning ice buried them again. The question is whether any such explorers existed, whether any civilization during the late Ice Age or early Holocene possessed the ships and the navigational knowledge to reach the bottom of the world. The official narrative says no. According to conventional history, the first humans capable of transoceanic voyages were the Polynesians, who began spreading across the Pacific around 3,000 years ago, and even they did not reach Antarctica. The age of European exploration did not begin until the 15th century, and Antarctica was the last continent to be discovered in 1820, when Russian and British expeditions independently sighted its icy coasts. Before that, the continent was unknown, a blank space on the map, Terra Australis Incognita, the unknown southern land, speculated to exist for reasons of symmetry but never confirmed. And yet, the maps suggest otherwise. They suggest that Antarctica was known, that its coasts were charted, that its interior features were observed and recorded not in 1820 but thousands of years earlier by a civilization capable of global navigation and sophisticated cartography. Who were they? The maps do not say. They offer no inscriptions, no names, no dates. They are copies of copies, the data degraded with each iteration, the source growing more distant and obscure with every generation of scribes and sailors who passed the knowledge forward without understanding where it came from or how it had been obtained. Some researchers have proposed that Antarctica itself was the source, that it was once the seat of an advanced civilization, a culture that arose during an interglacial period when the continent was habitable and was later destroyed when the ice returned. This is the Atlantis hypothesis applied to the southern hemisphere, a lost civilization buried beneath the ice, its cities and monuments crushed and scoured away by glaciers, leaving no trace except the maps, the memories encoded in myth, and perhaps, if we could ever excavate beneath the ice sheet, ruins waiting in the frozen dark. The hypothesis is speculative, but it is not absurd. If a civilization did exist in Antarctica during a warmer period, the subsequent glaciation would have obliterated nearly all evidence of its presence. Ice is a destroyer. It grinds bedrock to powder, pushes mountains aside, scours valleys clean. Anything built on the surface would be pulverized. Only structures deep underground, protected from the ice's crushing weight, might survive. And even those would be inaccessible, buried beneath miles of frozen water, invisible to all but the most advanced geophysical surveys. We have barely scratched the surface of Antarctica. We have mapped its subglacial topography, but we have not excavated it. We have drilled ice cores, but we have not dug through the ice to the rock beneath, except in a few isolated locations. The continent is the size of the United States and Mexico combined, and we have explored less than a fraction of a percent of what lies under its frozen shell. In 2001, satellite imagery detected a massive anomaly beneath the ice in East Antarctica, near the Soviet Vostok station. The anomaly, designated Lake Vostok, turned out to be a subglacial lake the size of Lake Ontario, liquid water sealed beneath more than 2 miles of ice. untouched by the surface world for at least 15 million years. The discovery revolutionized our understanding of Antarctica, revealing that beneath the ice lies an entire hidden landscape of lakes, rivers, and possibly even ecosystems adapted to extreme isolation and darkness. If life can exist in Lake Vostok, sealed away for millions of years, what else might exist beneath the ice? In 2013, Russian scientists drilled through the ice and reached the surface of the lake, extracting samples that revealed bacterial life, organisms that had evolved in complete isolation. The implications were staggering. Antarctica is not a dead continent, but a hidden one, its secrets preserved beneath the ice, waiting. If lakes can survive under the ice, could structures, could ruins? If a civilization built cities in coastal regions during a warmer period, and those cities were later overrun by advancing glaciers, they would now be entombed, frozen in place, preserved in the same anoxic, lightless conditions that have kept Lake Vostok pristine for eons. The maps hint at this possibility. They show more than just coastlines. Some depict inland features, rivers flowing from mountain ranges, valleys cutting through the interior, details that correspond to the subglacial topography revealed by modern ice-penetrating radar. The Piri Reis map, for instance, shows a river system in the interior of what appears to be Antarctica, flowing from highlands to the coast. Radar surveys have confirmed the existence of subglacial river channels in that region, carved into the bedrock, now filled with ice, but once flowing with water. How did Piri Reis know they were there? He could not have observed them directly. The rivers had been frozen for thousands of years by the time his map was drawn. He must have copied them from an older source, a map made when the rivers were still visible, still flowing, when Antarctica's interior was accessible and someone was there to chart it. The same is true for the mountain ranges. The bays, the coastal indentations, all match the hidden topography beneath the ice, features that would only be visible if the ice were removed, or more likely, if the maps were made before the ice arrived. There is one more unsettling detail. Ancient maps from various cultures, including Chinese and Polynesian charts, show landmasses in the Southern Ocean that do not correspond to any known geography, islands or continents that are too large to be minor Antarctic islands like South Georgia or the South Sandwich Islands, but too far south to be anything else. Some of these maps depict a vast southern continent extending far north of Antarctica's current ice line, suggesting either that the ice was much reduced during the period the maps were drawn, or that the cartographers were depicting Antarctica as it had been described to them, from memory or from earlier records, rather than from direct observation. If the latter, then the chain of transmission is even older than the ice-free period, extending back to a time when Antarctica was not just accessible, but inhabited, populated by people who knew its geography intimately and who passed that knowledge down through enough generations that it eventually reached the mapmakers of the Renaissance, distorted and incomplete, but still recognizable. The question of Antarctica is the question of memory. How far back does it go, and what do we do when the memory contradicts the timeline we have constructed? We can dismiss the maps as errors, as lucky guesses, as misinterpretations of ambiguous data, or we can take them seriously as evidence that someone, at some time, knew more about the world than we have given them credit for, that they explored farther, mapped more accurately, and survived longer than our history allows. Antarctica is still there, silent beneath its ice, holding its secrets. Until we excavate it, until we drill through the glaciers and dig into the bedrock, we will not know what lies beneath. But the maps are already speaking, and what they say is this: we were not the first to see the bottom of the world, and we are not the first to wonder what it hides. When the ice finally began to retreat and the floods receded, the world that emerged was unrecognizable. Coastlines had moved hundreds of miles inland. River valleys had become seas, forests had drowned, the megafauna, Mammoths, giant sloths, saber-toothed cats, cave bears had vanished, driven to extinction by the twin pressures of climate collapse and human predation. The survivors, whoever they were, found themselves in a landscape scoured clean, emptied of familiar landmarks, hostile and strange. They would have been traumatized, scattered, reduced to small bands clinging to high ground, to mountains and plateaus where the waters had not reached. Most of what they had known was gone, but some of them carried something more valuable than tools or shelter. They carried knowledge, seeds both literal and metaphorical, the seeds of plants that could be cultivated, the seeds of ideas, how to build, how to measure, how to observe the stars, how to organize labor, how to preserve memory. And in the centuries that followed, as the climate stabilized and the world became habitable again, these survivors descended from their refugees and began to teach, to spread what they remembered across the remnant populations, planting the seeds of civilization in soil still damp from the deluge. The suddenness with which agriculture appeared in multiple locations around the globe is one of the great anomalies of prehistory. Around 1,000 years ago, almost simultaneously, humans in the Fertile Crescent in China, in Mesoamerica and in the Andes began cultivating crops, wheat and barley in the Near East, rice and millet in Asia, maize and squash in the Americas, potatoes in South America. The conventional explanation is independent invention, the idea that different populations, facing similar environmental pressures as the Ice Age ended, independently discovered the principles of agriculture through trial and error. But the timing is suspicious. These regions are separated by thousands of miles, by oceans and mountain ranges with no evidence of contact or communication. Yet within a span of a few centuries, all of them made the same cognitive leap from foraging to farming, from nomadic to sedentary life, from egalitarian bands to hierarchical societies. The leap required not just recognizing that seeds grow into plants, but understanding selective breeding, soil fertility, irrigation, crop rotation, and storage. It required long-term planning and delayed gratification, planting now to harvest months later, a psychological shift from immediate consumption to future investment. And it happened everywhere at once, as though the knowledge had been distributed, as though someone was teaching. The myths speak of teachers. In Mesopotamia, the Sumerians told of the Apkallu, 7 sages who emerged from the sea before the flood, led by Oannes, a fish-like being who taught humanity writing, mathematics, agriculture, and law. The Apkallu were not gods, but emissaries, bearers of knowledge, and after the flood, they were said to have returned to instruct the survivors in rebuilding civilization. In Egypt, the god Thoth, depicted as an ibis-headed man, was credited with inventing writing, medicine, and astronomy, gifts he bestowed upon humanity in the time of Zep-Tepi, the first time. In Mesoamerica, Quetzalcoatl, the feathered serpent, was remembered as a culture hero who appeared among the people after a great catastrophe, teaching them agriculture, architecture, and the calendar. In the Andes, Viracocha, the creator god, was said to have traveled across the land after a flood, instructing the survivors in the arts of civilization, then departing across the ocean, promising to return. The same archetype repeats, a figure who comes from elsewhere, who possesses knowledge the locals do not, who teaches and then leaves, often with the promise or prophecy of return. These are not gods in the supernatural sense. They are described in human or semi-human terms as teachers, as wanderers, as survivors of an earlier age who carried the knowledge of the lost world into the new one. The genetic evidence supports the idea of migration and mixing. Studies of ancient DNA show that around 1,000 to 8,000 years ago, there were significant population movements and admixtures across Eurasia and into the Americas. These were not simple migrations of hunter-gatherers following game, but deliberate, directional movements of peoples carrying new technologies, pottery, polished stone tools, domesticated plants and animals. into regions where these things had not existed before. In Europe, the Neolithic revolution was brought by incoming farmers from Anatolia and the Near East, peoples who displaced or intermingled with the indigenous hunter-gatherer populations. In India, the introduction of agriculture correlates with the arrival of new genetic lineages from the West. In the Americas, the genetic record is more complex, but it shows multiple waves of migration and admixture, not a single crossing of the Bering Land Bridge, but a series of arrivals, some by land, possibly some by sea, bringing different technologies and cultural practices. These movements are not random. They follow coastlines, river valleys, and trade routes, as though the migrants knew where they were going, as though they had maps, as though they were part of a coordinated effort to reseed the world with the knowledge and the crops that had survived the catastrophe. The crops themselves are another mystery. Domestication is not a quick process. It requires generations of selective breeding to transform a wild plant into a reliable food source. Wild wheat has seeds that shatter and disperse when ripe, making them difficult to harvest. Domesticated wheat has non-shattering seeds that remain on the stalk, a mutation that occurs rarely and must be selected for over many generations. The same is true for maize, which barely resembles its wild ancestor, teosinte, a grass with small, hard kernels. The transformation from teosinte to maize required deliberate selection for larger kernels, more rows per cob, and softer husks, a process that should have taken centuries, if not millennia, of trial and error. Yet the archaeological record shows that domesticated crops appeared rapidly, often fully developed within a few hundred years. Either the domestication process was much faster than we think, or it had already been completed elsewhere, and the domesticated varieties were introduced to new regions by people who already knew how to cultivate them. The latter explanation fits the pattern of sudden agricultural emergence better than the former. It suggests that agriculture was not invented independently multiple times, but was developed once in a single location or by a single culture, and then spread by survivors who carried the seeds and the knowledge to different parts of the world. Where was the original center of domestication? The Fertile Crescent is the conventional answer, the region where the earliest evidence of agriculture appears. But the Fertile Crescent was not the most fertile region before the Ice Age. During the last glacial maximum, it was cold, arid, marginal land. The most fertile regions were the now drowned coastal plains, the river deltas and estuaries that are now under hundreds of feet of seawater. If agriculture was developed in those regions, during the warmer periods of the Ice Age or just before the meltwater floods, then the original centers of domestication are lost, submerged, accessible only through underwater archaeology in areas we have not yet explored. The Fertile Crescent may not be where agriculture was invented, but where it was reintroduced, brought by survivors fleeing the rising seas, carrying seeds from the drowned fields of the coast. This would explain the sudden appearance, the lack of precursor phases, the sense that the early farmers already knew what they were doing. They were not experimenting. They were remembering or following instructions passed down from those who remembered. The same pattern appears in architecture. The earliest monumental structures, Göbekli Tepe, the megaliths of Karnak, the stepped pyramids of Peru, appear suddenly, fully realized, with no visible learning curve. They are not crude first attempts, but sophisticated designs, executed with precision, as though the builders were following templates, working from knowledge that predated the structures themselves. Some researchers have proposed that the megalithic tradition was spread by a seafaring culture, survivors of the flood who traveled the coasts, teaching local populations how to quarry stone, how to align structures to the stars, how to build monuments that would endure. The similarities in construction techniques, massive stones fitted without mortar, astronomical alignments, use of specific geometric ratios across widely separated sites, support this idea. The builders of Göbekli Tepe, the builders of the Egyptian temples, the builders of Tiwanaku and Sacsayhuaman may not have been isolated cultures independently discovering the same methods. They may have been students of the same teachers or inheritors of the same tradition, a tradition that originated before the flood and was carried forward by those who survived. The survivors did not rebuild the world as it was. They could not. Too much had been lost, too many people dead, too much knowledge forgotten. But they preserved what they could, planting seeds both literal and figurative, teaching the remnant populations enough to ensure that humanity would not fall back into complete ignorance, that the journey from stone tools to cities would not have to be repeated from scratch. They gave us agriculture, the foundation of sedentary life. They gave us astronomy, the ability to track time and predict seasons. They gave us architecture, the knowledge of how to build structures that align with cosmic order, and they gave us memory, encoded in myths and monuments, stories of the world before, warnings and promises that if we listen carefully, we might avoid the same fate. The survivors are nameless. We do not know their cities or their kings, but we know they existed because the seeds they planted are still growing, still bearing fruit, still shaping the world we live in. Every time we plant a field, every time we build a temple, every time we look up at the stars and recognize a pattern, we are continuing their work, carrying forward the knowledge they fought so hard to preserve. The flood tried to erase them, but they refused to be forgotten. They scattered their legacy across the world, trusting that someday someone would piece it together and understand what they had done, what they had saved, and what they had lost. The earth itself keeps records more reliable than any human archive. Inscriptions written in stone and ice and sediment that cannot be altered by conquest or rewritten by ideology. Layers of ash mark ancient eruptions. Pollen grains trapped in lake beds reveal what plants grew when. Oxygen isotopes in ice cores trace temperature fluctuations across hundreds of thousands of years. And in these records, in the silent testimony of geology, there is a chapter that reads like catastrophe, a period of violent transition so abrupt and so devastating that it defies the gradualist assumptions upon which much of modern science is built. The end of the Pleistocene, the boundary between the Ice Age and the present interglacial, is marked not by slow thawing, but by chaos, sudden temperature spikes, massive flooding, extinctions on a scale that wiped out entire families of species within centuries. The geological record does not describe a gentle awakening into the Holocene. It describes trauma, disruption, and upheaval on a planetary scale. And if humans were living through this period, if they had built cities and cultures along the coasts and river valleys that were obliterated by the rising seas, then the geology is not just recording climate change, it is recording the end of their world. The Younger Dryas is the pivot point, the event that interrupts the warming trend and plunges the planet back into cold for more than 1,000 years. It begins abruptly around 2,800 years ago, temperatures dropping by as much as 15 degrees Celsius in some regions within a decade, glaciers re-advancing, forests dying back, ecosystems collapsing. The cause has been debated for decades. Some scientists point to disruptions in ocean currents caused by the sudden influx of meltwater from collapsing ice sheets. Others propose volcanic eruptions or changes in solar radiation. But a growing body of evidence supports a more dramatic explanation, an extraterrestrial impact, a comet or asteroid that fragmented in the atmosphere and rained down across the northern hemisphere in a series of airbursts and ground strikes. The evidence is found in a thin layer of sediment dated to the onset of the Younger Dryas, a boundary layer that contains materials that should not exist in natural geological deposits: nanodiamonds, spherules of melted rock, platinum and iridium anomalies, carbon-rich particles consistent with continent-scale wildfires. These are the signatures of impact, of immense heat and pressure, of materials formed only under conditions of extreme violence. The Younger Dryas Impact Hypothesis, proposed by Richard Firestone and others in 2007, remains controversial, but the evidence continues to accumulate. In 2018, researchers identified a massive crater beneath the Hiawatha Glacier in Greenland, a structure 31 kilometers wide that appears to date to the late Pleistocene. If confirmed, this would be direct physical proof of a major impact at precisely the time the Younger Dryas began. The explosion would have vaporized billions of tons of ice, injecting vast quantities of water vapor and debris into the atmosphere, triggering immediate climate disruption. The thermal pulse would have ignited forests across North America and Europe, creating firestorms whose smoke and ash would have darkened the sky, blocking sunlight, cooling the planet. The meltwater from the vaporized ice, combined with the destabilization of ice sheets already weakened by millennia of warming, would have caused catastrophic flooding, sudden pulses of sea level rise that drowned coastlines and river deltas in a matter of decades. This is not gradual climate change. This is apocalypse, sudden and total, a reset event that any human civilization living through it would have experienced as the end of the world. The megafaunal extinctions support this timeline. At the end of the Pleistocene, dozens of large mammal species disappeared from North America, Europe, and Asia. Mammoths, mastodons, giant ground sloths, saber-toothed cats, giant beavers, short-faced bears, dire wolves. These were not gradual die-offs, but sudden collapses. Populations crashing within centuries, many species vanishing entirely. The extinctions coincide with the onset of the Younger Dryas, and their pattern suggests not just climate stress, but catastrophic disruption. In North America, the extinctions are particularly sharp, with entire genera disappearing almost simultaneously. Their bones found in layers associated with burn marks, impact debris, and evidence of sudden environmental collapse. Some researchers have argued that human overhunting drove the extinctions, the so-called Pleistocene overkill hypothesis. But this explanation struggles to account for the speed and scale of the die-offs, or for the fact that many of the extinct species had coexisted with humans for thousands of years without being hunted to extinction. The impact hypothesis provides a more comprehensive explanation. The animals died not because of slow predation, but because their habitats were destroyed, incinerated by firestorms, buried by ash, flooded by rising seas, frozen by the returning cold. Meltwater Pulse 1A, occurring around 14,600 years ago, raised global sea levels by 50 feet in less than 500 years. Meltwater Pulse 1B, around 11,500 years ago, added another rapid surge. These were not gentle rises, but catastrophic inundations, the kind of events that would have drowned entire civilizations, if any existed, along the vulnerable coastlines. The Persian Gulf, which had been a fertile river valley during the Ice Age, was flooded and became the shallow sea we know today. The Black Sea, once a freshwater lake, was inundated by the Mediterranean breaking through the Bosphorus, an event so sudden and violent that it may have raised the lake's level by hundreds of feet in a matter of months, drowning settlements along its shores. The English Channel was carved out by meltwater, separating Britain from continental Europe. Doggerland, a low-lying plain connecting Britain to the Netherlands and Denmark, was submerged, transforming a habitable landmass into the North Sea. In Southeast Asia, Sundaland, a subcontinent that had connected Malaysia, Indonesia, and Borneo during the Ice Age, was flooded, reducing a vast habitable region to scattered islands. The total area of drowned land is staggering, estimated at 25 million square kilometers, roughly the size of North America. If humans had settled these regions, and there is every reason to believe they would have, coastal zones are rich in resources, temperate in climate, ideal for habitation, then those settlements are now underwater, buried under sediment, invisible to conventional archaeology. Marine geologists conducting surveys for oil and gas have occasionally stumbled upon anomalies on the continental shelves. geometric formations that do not fit natural geology. Off the coast of India, in the Gulf of Cambay, sonar detected what appeared to be rectilinear structures 120 feet below the surface in areas that would have been dry land during the Ice Age. Off Japan, the Yonaguni Monument displays terraces, steps, and right angles that some researchers argue are too regular to be natural erosion. Off the coast of Cuba, deep ocean sonar revealed symmetrical stone structures at depths of 2,000 feet, far deeper than any known ancient construction, leading to speculation that they predate the last ice age entirely. None of these discoveries have been definitively proven to be artificial, and mainstream archaeology remains skeptical, but the pattern is suggestive. The ocean floor is littered with formations that resemble architecture, and until we conduct systematic underwater excavations in the regions that were coastal plains 15,000 years ago, we will not know what lies beneath. The geological testimony is clear. Vast areas of habitable land were drowned rapidly at the end of the Ice Age. Whether those areas were inhabited is the question we have not yet been able to answer, because the evidence, if it exists, is submerged and largely unexplored. Ice cores from Greenland and Antarctica provide another layer of testimony. Drilled from the ice sheets, these cores preserve a continuous record of atmospheric conditions stretching back hundreds of thousands of years. Each annual layer contains trapped air bubbles, dust particles, volcanic ash, and isotopic signatures that reveal temperature, precipitation, and atmospheric composition. The cores show that the end of the Pleistocene was not a smooth transition, but a period of extreme volatility, with temperatures swinging wildly, precipitation patterns shifting, atmospheric dust levels spiking in ways consistent with massive wildfires and impact ejecta. The Younger Dryas appears as a sharp anomaly, a sudden intrusion of cold in a warming trend, lasting 1,200 years before ending just as abruptly as it began. The termination of the Younger Dryas around 1100 years ago is marked in the cores by a dramatic spike in meltwater, a pulse so large that it raised sea levels by several meters in a matter of decades. This is the final flood, the last great inundation, the event that would have completed the drowning of the Ice Age coastlines and forced any remaining coastal populations to flee inland or perish. The ice cores do not lie. They record what happened with chemical precision, and what they record is catastrophe. The geological testimony does not prove that a lost civilization existed before the Ice Age, but it proves beyond doubt that any civilization existing during that period would have faced extinction-level challenges. The climate was unstable, lurching between warm and cold. The coasts, where humans naturally congregate, were drowned by rising seas. The continents were racked by earthquakes and volcanic eruptions as the crust rebounded from the removal of ice weight. The sky was darkened by ash and smoke. Food chains collapsed. Megafauna died, and through all of this, humans, who we know were present, who we know were intelligent, who we know were capable of innovation and adaptation, had to survive. Some did. We are here. But how many did not? How many communities, how many knowledge systems, how many languages and technologies were lost in that crucible? The geology tells us the scale of the disaster. It does not tell us the human cost, because the humans, if they left any record, left it in places we have not yet looked, under ice we have not yet drilled through, under seas we have not yet explored. The earth remembers what we have forgotten, and it is still speaking in layers of sediment, in cores of ice, in the bones of extinct animals and the drowned valleys of vanished rivers. We have only to listen, to dig, to drill, to dive, and perhaps we will finally hear the full story of what the world endured when the Ice Age ended and the waters rose. When all else fails, when the monuments crumble, when the tablets dissolve, when the cities sink beneath the sea, there remains one medium that can carry knowledge across chasms of time so vast that they swallow empires whole. That medium is story. The human mind is a recording device, imperfect but persistent, capable of preserving information through oral transmission for thousands of years if the story is important enough, if it is repeated with ritual precision, if it is embedded in sacred narratives that communities refuse to let die. We have underestimated myth, dismissing it as primitive fantasy, as the confused dreams of people who did not yet know how to think rationally. But what if myth is not confusion but compression, not fantasy but encrypted history? The only way pre-literate cultures could preserve complex information about real events, real people, real catastrophes. What if the gods who appear in every ancient tradition, the teachers, the culture heroes, the bringers of knowledge who arrive after floods and instruct survivors in the arts of civilization, are not supernatural beings, but historical figures, distorted by millennia of retelling, but still recognizable if we learn how to decode the stories they inhabit? The pattern is too consistent to ignore. Across the world, separated by oceans and languages, cultures tell the same story. After the flood, a figure appears. He is not from here. He comes from the sea, from the east, from the heavens, from somewhere else. He is wise. He teaches agriculture, astronomy, law, writing, architecture. He stays for a time, long enough to establish the foundations of civilization, and then he departs, often with the promise or prophecy that he will return. In Mesopotamia, he is Oannes or Enki, emerging from the Persian Gulf in the form of a fishman, teaching the Sumerians the Mi, the divine principles of order. In Egypt, he is Thoth, the ibis-headed scribe who brings writing and measurement, or Osiris, who teaches agriculture and law before being murdered and resurrected. In Mesoamerica, he is Quetzalcoatl, the feathered serpent, a bearded man in white robes who appears among the Maya and Aztec, teaching them the calendar and the cultivation of maize before sailing away across the eastern sea. In South America, he is Viracocha, the creator and teacher, who walks across the Andes after a great flood, instructing the people in building and farming, then departing across the Pacific. In India, he is Manu, the first man, saved from the flood by a fish who becomes Vishnu, who then teaches the survivors how to rebuild. The details vary, but the function is identical. These are post-catastrophe instructors, carriers of knowledge from a world that no longer exists. Conventional scholarship interprets these figures as mythological archetypes, symbolic representations of the transition from hunter-gatherer to agricultural society, personifications of the knowledge itself rather than actual teachers. But the descriptions are often startlingly specific, too detailed to be pure symbol. Quetzalcoatl is described as tall, bearded, light-skinned, unlike the indigenous population, wearing robes and a pointed hat, carrying instruments of measurement and writing. Viracocha is similarly described as different in appearance, a stranger who arrives by boat, carrying tools and knowledge unfamiliar to the locals. Oannes is depicted in Babylonian reliefs as a figure wearing a fish-skin cloak, which some interpret as a diving suit or protective garment, teaching the people during the day and returning to the sea at night. These are not vague deities. They are described with the specificity of historical figures, remembered through oral tradition and later mythologized as their deeds were magnified and their origins obscured. If they were real, if they were survivors of the antediluvian world carrying remnants of lost knowledge, then myth is doing exactly what we would expect, preserving their memory, garbling the details, elevating them to divine status, but retaining the core narrative that they existed, they taught, they changed the course of history. The Aboriginal Australians provide a compelling example of myth's durability. Their oral traditions, passed down through tens of thousands of years, describe landscapes that no longer exist, events that can be correlated with geological changes at the end of the Ice Age. Stories tell of islands that were once connected to the mainland, of seas that rose and drowned the land, of specific locations that are now underwater but which archaeology and bathymetry confirm were once habitable. One tradition from the Yolngu people of northern Australia describes a time when the land extended far to the north, when people could walk to what are now islands in the Arafura Sea. Sea level data confirms that these islands were connected to the mainland during the Ice Age and were separated by rising seas around 1,000 years ago. The stories are not vague allegories. They are geographic memory, accurate to a degree that suggests continuous transmission across 400 to 500 generations. If the Aboriginals can preserve accurate information for 10,000 years through oral tradition, why couldn't other cultures? Why couldn't the flood myths of Mesopotamia, Egypt, and the Americas be equally accurate, equally rooted in real events witnessed by real people? The Polynesian navigators preserved knowledge through oral tradition with similar precision. They carried in their minds detailed maps of the Pacific, memorized sailing directions, star paths, wave patterns, and seasonal wind shifts that allowed them to navigate thousands of miles of open ocean without instruments. These navigational chants, passed from master to apprentice, encoded information that was functionally equivalent to written charts, and they did so for centuries before contact with European explorers. The knowledge was sacred, protected, transmitted with ritual exactness to prevent corruption. This is how oral tradition works, when it is treated as essential, when the community's survival depends on its accuracy. The same mechanisms that preserved Polynesian navigation could have preserved flood narratives, astronomical knowledge, and accounts of pre-catastrophe civilizations. Myth is not a degraded form of history. It is a specialized form, adapted to survive without writing, structured to resist distortion through repetition, embedding crucial information in memorable narratives that communities reenact and retell until the story becomes inseparable from identity itself. There is another layer to this encoding, one that suggests intentionality. Many myths contain numerical and astronomical data embedded in their structure, ratios, and cycles that correspond to real celestial phenomena. The Vedic texts describe yugas with durations that, when decoded, align with precessional cycles. The Mayan long count calendar, encoded in myth and ritual, tracks the 26,000-year Great Year with precision. The Egyptian myths of Osiris and Set, of death and resurrection, mirror the heliacal rising of Orion and Sirius, astronomical events that marked the Nile's flood and the Egyptian New Year. These are not coincidences. They are mnemonic devices, stories structured to preserve data about cosmic cycles, celestial positions, and calendrical calculations. If you wanted to preserve knowledge across a catastrophe that would destroy all written records, you would do exactly this. Encode it in story, make it sacred, tie it to ritual reenactment, and trust that future generations would continue the tradition even if they no longer fully understood what they were preserving. The myths are not just memories. They are archives, oral hard drives storing information in narrative form, waiting for a time when humanity would be ready to decode them. The figure of the culture hero may represent not a single individual, but a class of individuals, a group of survivors from the antediluvian world who scattered after the catastrophe and took on the role of teachers, spreading what they knew to the remnant populations they encountered. This would explain why the same archetype appears in so many places, not because the stories spread through diffusion, but because the teachers themselves spread, traveling by sea to different continents, each becoming the founding figure of a new post-catastrophe civilization. The bearded man in white robes, who teaches the Maya, might be a different person than the one who teaches the Andean peoples, but they might both belong to the same culture, the same tradition, the same group of survivors carrying the same body of knowledge. Their appearance would have been miraculous to people who had lost almost everything, who were struggling to survive in a world transformed by climate collapse and rising seas. And so they were remembered as gods. their deeds magnified, their origins spiritualized, but the fact of their existence, the fact that they taught, the fact that they changed the trajectory of human development, that would remain embedded in myth, waiting to be recognized for what it is. We stand now at a threshold, a moment when we possess the tools to test these myths, to compare them against geology, against archaeology, against genetics and astronomy. The flood myths can be correlated with meltwater pulses. The culture heroes can be mapped against the spread of agricultural and architectural knowledge. The astronomical data encoded in sacred narratives can be verified against the actual positions of stars in ancient skies. And as we do this work, a picture is emerging, fragmentary but coherent, of a world that existed before the one we know, a world that ended in catastrophe, a world whose survivors became the founders of what we call the first civilization. The myths are not lies. They are testimony, garbled by time, elevated by reverence, but rooted in events that people witnessed, endured, and refused to forget. The memory encoded in myth is humanity's longest-running archive, older than any tablet, more durable than any monument, carried in the minds of storytellers across 1,000 years of retelling. We have spent centuries dismissing it, and in doing so, we have dismissed the voices of the people who lived through the end of the Ice Age, who watched the floods rise, who fled to the mountains, who carried the seeds and the knowledge forward, who became the teachers and the gods of the new world. If we listen now, if we decode the stories with the respect they deserve, we might finally hear what they have been trying to tell us all along. That we are not the first, that the world has ended before, and that memory, fragile and distorted as it may be, is the only thing that survives when everything else is drowned. The myths remember what history forgot, and they are still speaking, waiting for us to stop calling them fantasy and start calling them by their true name, the last testimony of the world before the ice. If these voices from the Ice Age stirred something in you, consider subscribing. The past is deeper than we've been taught, and there are more stories waiting beneath the surface. Until next time, may you rest well, dreaming of the worlds that came before ours.